Hello Year 11, welcome to the second lesson of polynomials for exercise 10b, graphs of polynomial functions. Now I know a lot of you have been complaining about sketching functions in general, how you guys struggle with them. So this exercise was meant to be an investigation task that I set for students. So if you read the instructions here, I tell the students to use Desmos to find out some features of polynomial functions and create a manual about how to graph a polynomial function. So you're meant to come up with your own steps, but if it's a bit difficult, then maybe just read the solutions that I'm going to go through. Or if you have time, take this time to actually consider these things and try to come up with your own manual. And then when I go through the actual manual, then you can sort of compare the similarities and differences, and you can fix it if you want. Now, some things to consider when you're graphing is how does the degree of the polynomial affect the shape? How does the leading coefficient affect it? And what do we do with the zeros of the polynomial? And what do we mean by multiple roots / zeros? I wrote them down because they're probably the most crucial things that you need to consider. Probably the only things, I think. If you have those four informations, then that's pretty much all you need to graph a polynomial function. And then after creating the manual, I get the students to give me a neat solution of this function. Sorry, not a solution. Right. I probably meant graph a solution. Oh, it says how to graph a function. I wasn't really asking for the how, actually. I was just asking for a neat sketch of the function. So you can pause the video and try it by yourself, or if you're not confident, just follow along. Now, this is that's what I've given to the students last year. And if you scroll, no, I'm scrolling. If I scroll down, this is actually the submission that I had from a student, which I thought deserved a full mark. So I gave ticks, 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 and I said, excellent. So let's have a look at what this student wrote in her response. So first of all, she's identified that the zeros of the polynomial are meant to be the x-intercepts. This one, she got a little bit of a cross, but I can explain that later. Now, in her solution, she talked about ends of graph. So to identify a degree of the polynomial, she's identified it into even degree versus odd degree. If you have an even degree, so the highest power of x is 2, 4, 6, or any even number, the ends of the graph are going to be pointing the same direction. And then she's also identified it in different categories. She talked about positive leading coefficient and negative leading coefficient. So if your degree is even and you've got a positive leading coefficient, she knew that the ends will be facing upward because we actually have to end on a positive. But for an even degree with a negative leading coefficient, both of the ends will be pointing downwards because we know we have to finish on a negative. So the leading coefficient is all about where it finishes, and whether it is even or odd will be the direction of either ends. So let's hop onto the odd degree. You can see that for both of the odd degree function, the end points are facing different directions. But we follow the same logic for the leading coefficient. If it's positive leading coefficient, we need to end on a positive. So that means we start from negative infinity. And for a negative leading coefficient, we need to finish at a negative. So we start from positive infinity. Hopefully that makes sense. So knowing the degree and the positive leading coefficient already tells us the direction of the both end points for a polynomial. So that's a big info. Now, to graph the zeros of the polynomial, as she's identified before, you're basically solving for the x-intercept. So you let the function equal to 0, and you graph them as the x-intercepts. Now multiple roots, she's actually identified it again here and she got them all correct. She wrote, when there are multiple roots, for example, if there are powers on the brackets of a factorized expression, you need to check whether this power is even or odd. So she wrote, when the power is even, it bounces at the zeros smoothly. If you look at the diagram, it would be zeros like that. It bounces and curves back. If the power on the bracket is odd, then it passes through the zeros, but it becomes a point of inflection. So have a look at a point like this. It does pass through, as in it doesn't bounce off, but it doesn't cut through straight away. It sort of curves in and out, making it look like a point of inflection that we talked about back in chapter 4 of Year 12 Advanced. So that is also a good point to consider if you've got powers on the factorized brackets, because that's going to change the shape of the graph. So for the final result, that was the equation that she had to sketch. You can see that she sketched the x-intercepts of 3, 1, and -2. At the x-intercept 3, there's no power on the bracket, so it just cuts through like that. On x-intercept of 1, you can see that there is a power 3, so it has to curve like a point of inflection. And for the third one, -2, you can see the power is 2, which is even, so it bounces off. So if you don't consider that, you will actually have the end points pointing the wrong directions, which you will find out eventually, but then you want to get it right at the start. Let's think about the previous dot points as well. If you look at the degree of this polynomial, we've got power 1, we've got power 3, power 2, multiply the terms all together, then you're adding the indices. So the degree of this polynomial f of x is 6 here, 1 plus 3 plus 2. So we know that the endpoints will be facing the same directions. And if you look at the leading coefficient, we got x squared times x cubed times x times -3. I'll just say leading coefficient is -3. And it's a negative number, so we know we have to finish with a negative. Hence, both of the endpoints facing downward. And that's just something you can use to double check if the shape is correct or not. Finding the y-intercept also helps in identifying which side the polynomial has to lie. But yeah, with all these info, that should be plenty of information for you to sketch a polynomial. And she's also written very detailed steps on how she sketched that. So yeah, that's what I was looking for in the investigation, but a lot of students were a bit confused and they couldn't really organize all the information in a neat manual, but I think this one was the best response I've had so far, hence why I've included in my notes. Yeah, it's pretty much the same thing as I wanted to say, but she's organized it in a really good manner. So you can you can copy these notes down, or maybe now that you've got a better idea, you can actually try and go back to the investigation task and try it yourself, or even put it in any better format if it helps for you. But yeah, that's pretty much it for the steps on how to draw any polynomial function. Now for this one, the homework. Oh, I thought I had the homework on the bottom of the page. I think it just disappeared, but maybe I'll just write it down here again. The homework for this exercise will be exercise 10b. Questions 4, 6, 7. That's all you have to do for this exercise. Well, that's it. I will see you in the next video. Bye!